Hi everyone and welcome. I just got the PCBs for Throttle Blaster Revision 0.3. The PCB will replace the prototype board I was using until now. In case you're not familiar with the project, feel free to refer to one of my previous videos. In short, it is a circuit based on a Raspberry Pi Pico that allows you to reduce the speed of a fast CPU by sending pulses to the stop clock pin. This allows you to play early speed-sensitive DOS games like Digger on a fast Windows era machine. You control the speed using a knob or buttons, and you even get to see the current frequency in a 7-segment MHz display. In the latest revision, 0.3, you can even control it via the serial port, so you can launch your games in the correct speed with a batch file. For the full version of the board that supports all input types, these are the components you need. Several headers, two 1206 resistors, 100 ohms and 1K, a 2N7000 N-channel transistor, a diode for reverse polarity protection. Any diode should do, as the Pico works fine well below 5 volts, and the display also seems to work fine one diode drop under 5 volts. Two jumpers for selecting the input mode, a TM1637 based display module, a 5-pin rotary encoder with a built-in button, but you can skip this if you're planning to use buttons or a potentiometer. Finally, if you're planning on controlling the Throttle Blaster from the serial port, you can use a Max 3 232. This needs several 1 microfarad 1206 capacitors. Oh, I forgot to show the small ceramic capacitor used to help smooth the values of the potentiometer. Here it is, next to the other small components. Okay, let's build it. This time I'm gonna use some very cheap lead-free solder and no extra flux, so let's see how it goes. Please make sure you insert the Pico the correct way in, otherwise you will damage it. Okay, now that we've put everything together, let's configure the jumpers. We're using a rotary encoder, so our configuration is the first row, JP1 closed and JP2 open. Okay, now let's connect the display module. As you can see, the pins on the module are marked with clock, DIO, ground and 5 volts. The same markings are shown on the display header on the Throttle Blaster, so all we need to do is connect the two with a DuPont cable. Now let's flash the Throttle Blaster firmware onto the Pico. This is straightforward. You just need to press the boot cell button, and while holding it down, you insert the USB cable to your computer. The Pico will show up as a mass storage device like a flash drive. All you need to do is copy the .uf2 firmware file to the Pico and safely eject the mass storage device on your operating system. Soon after, the Pico's LED should light up, which means that the Throttle Blaster firmware is up and running. If you have a display connected, it should show the default CPU frequency. In my case, it reads the last configuration stored in the Pico's flash, so it shows 1200 MHz. Now let's see how we are going to power it on. Well, you could obviously power it from the Pico's micro USB port. In that case, you should make sure that the Throttle Blaster's ground is connected to the target system's ground, otherwise throttling won't work. The best way is to power it from the system's power supply using a floppy power connector. The header pins are marked with 5 volts and ground, so please make sure you insert it the right way in. The red cable is 5 volts and the yellow cable is 12 volts. So be very careful. Inserting the power connector the wrong way in will fry the Pico, the display and the Max 3232. Now let's take a look at these other headers. The 2-pin headers on the left are for the right and left buttons, and RV1 is for the potentiometer. If you decide to use any of these, you need to reconfigure the jumpers JP1 and JP2 and power cycle the device. Before we move on, a quick note about how you may mount the Throttle Blaster on a PC. You may use a 5 1/4 drive bay cover, drill a hole for the rotary encoder and mount it there. You might as well place the MHz display next to it. Okay, now let's take a closer look at the 3-pin serial header. I'm going to build the serial cable the lazy way, by soldering some pre-made DuPont cables to the serial port connector. We're going to use pins 2, 3 and 5, which correspond to RX, TX and ground. We connect ground to ground, then we connect the serial cables RX to the Picos TX, and the cables TX to the Picos RX. Now let's focus on header J1, which is where we should attach the cable that drives the stop clock pin on the CPU. As you may recall from the previous videos, I'm using a very thin wire which I have inserted into the socket along with the CPU. Crimping a DuPont connector to it won't work, so I'm going to use a pre-made wire with DuPont connectors and solder the thin wire to it. Okay, we're almost set. Nice, it looks much better now. Let's check that it works. And yeah, it's working great. Now let's see how we can control the Throttle Blaster from the serial port. In DOS, we can use the Serial Terminal Emulator program Kermit, which can also be used for one-liners. We first need to tell it which serial port to use, which is COM1 in our case. Next, the baud rate, which is 9600, and then the characters to control the Throttle Blaster. F733 means a frequency of 733 MHz. P8 means a PWM period level of 8. \13 is ASCII character code 13, which is the carriage return character. And as you can see, the display shows that it received a UART command. F0 brings us back to the default CPU frequency. A non-recognized command will print UError in the MHz display. Let's try it out by setting the frequency to 33 MHz. And yeah, the benchmarks run super slow. Moving the knob overrides the UART command. Okay, that's all for today. The sources and the gearware files for the PCB can be found on the projects page on GitHub. I hope you enjoyed the video, and as always, thanks for watching and goodbye.